Visually impaired people find it challenging to engage with and experience their surroundings. Physical mobility is difficult for visually impaired people since it is difficult to differentiate barriers in front of them, and they are unable to go from one location to another. Over the last few decades, scientists have been working on new gadgets to create a good and dependable system for visually impaired people to identify obstacles and notify them when they are in danger. In this project, a blind stick for blind people has been improved into a smart blind stick using a board and a microcontroller. Smart blind stick will be very helpful for the blinds. The smart blind stick will help them by warning them those nearby objects that may obstruct the blind people by producing alarming sound to alert the blinds. The sound helps the disabled by beeping the LED, which will going to alert them by beeping as a sign of presence nearby object.
Assalamualaikum, my name is Adi Aiman bin Makno. My metric number CD19014. So I want to explain to you about objective. First, to develop a blind stick system using the Mega Arduino. Second, to learn how to use basic electronics components. 3, to demonstrate the stick that is reliable and convenient for the disabled people. Next, scope. First, focus on developing a blind spot system that notifies the blind people. Second, only use the Arduino system to develop the sonar system by ultrasonic sensor. 3, material to develop the model is made from cheap and easy to get. Next, list of components. HCSR04 ultrasonic sensor, which is to detect the obstacle by transmitting sonar and receiving back the distance of any object present. Second, active buzzer module to generate a high pitch frequency that alerts the eardrum. Third, 3-color LED module to transfer light and provide warning in terms of light transmission. 4, 9-volume battery and battery holder. In order for the Arduino Mega and other components to function properly, electricity must be supplied. 5, Arduino Mega is act as the system's brains, processing all received signals and determining the system output. Lastly, male to female jumper to connect the electrical circuits of the components.
I am Ahmad Fathan bin Ahmad Fazuli. My metric number is AD1900176. Let's proceed with our coding for blind stick project. First of all, we define pins number. Technically, we use 3 major components, which is RGB LED, ultrasonic sensor, and buzzer. First of all, for the key, for the leg of LED for red, we define at key pin number 8. For green, at key pin number 9. For blue, at key pin number 10. For ultrasonic sensor, echo pin, we define at key pin number 11. Trick pin defined at key pin number 12. For buzzer, the cathode we define at key pin number 13. Second, we define variable. Variable that we use is duration. We define as long. Distance and safety distance we define as integer. For call function void setup, pin mode, trick pin as our output at ultrasonic, echo pin as our input. For buzzer and RGB LED is our output. We set the serial begin at 9600 ms. Void loop, first of all, clears the trick pin low. We set the delay microseconds at 2. Set the trick pin on high state for about 10 microseconds. The trick pin is initiated as high and delay microseconds at 10. Digital write, we set the trick pin low back. For the echo pin, to return the sound wave travel time in microsecond, so the duration equal to pulse in, the echo pin will function high. To calculate the distance from object to the stick, the distance equal to duration times 0.034 over 2. We divide by 2 because the frequency is the way of the vibration travel forward and back. So that's why we divide over 2. And 0.034 is our frequency. Safety distance is equal to the distance to call back the safety distance. for the if else function. For if else functions, if safety distance is less than or equal to 5, the buzzer will set as high and the LED red equal to 255, LED green 0, LED blue 0. So this will initiate the LED to light up in red color. Else, if the safety distance more than 5, the digital buzzer will not making any sounds and the LED red equal to 0, LED green 255, LED blue 0. So this will initiate the LED to turn on the green one for the safe indication. Prints the distance on the serial monitor. So after that, we simply print all the command into the Arduino Mega. This is next schematic diagram for HCSR04. For ground, we simply put into ground. VCC, we use 5 volt is enough to power up the ultrasonic. For buzzer, there is three leg actually, but in the Tinkercad only have model 2. So for the minus, we put into ground. For S, we set into the key pin 13, and the third one, we set into the 3.3 volt. For the LED, RGB LED, for the red one, we set at key pin number 8. For the green one, we set at the key pin number 9. For the blue one, we set at key pin number 10. The cathode will move to the ground. At the ultrasonic sensor just now, the trip pin is at 11 and the echo pin is at 12.
Assalamualaikum warahmatullahi wabarakatuh. My name is Najib Haidi Manuspan, and now I will proceed to our experimental procedure. First thing, we need to get the PVC pipe, the ultrasonic sensor, 9-volt battery with battery holder, an active buzzer module, a 3-color LED module, male to female jumper, and cable ties, and also Arduino Mega. The second step, we need to take an adequate amount of cable ties and secure the HCSR04 ultrasonic to the end of the stick. And then at above of the ultrasonic sensor, we place the Arduino Mega and we connect the jumper wires to the sensor. After we connect the jumper wire to the sensor, we connect the sensor's VCC to 5 volt, TRIG to Arduino pin 12, GND to GND, and the echo to Arduino pin 11. Next, we connect the active buzzer module's negative to GND and the positive to Arduino pin 13. And the last buzzer pins, we connect it to the power supply, which is a VCC. And next, we use scotch tape to tidy up the 3-volt DC buzzer on the stick. Next, we connect each of the 4 pins of 3-color LED module on pin 10, 9, 8, and GND. And the 8th step, we assemble procedures. The assembly procedures we can refer it by follow the schematic diagram which we provide at the figure 1. And next, we trim away any extra binder using scissors or any sharp tools that is necessary. And lastly, before we test the blind stick, please make sure that we have uploaded the coding program from the programming coding system. So that's all from me. Thank you.
Hi, my name is Elson Soundrapaman and I'm gonna explain the results and the discussion of our project, which is the Smart Blind Stick. So the Smart Blind Stick has been successfully assembled as we see in the picture on the left hand side. So compared to a normal blind stick, what is special about the Smart Blind Stick? So it could scan the blind's path in front of it with the help of HCSR04 ultrasonic sensor. And the Arduino Mega microcontroller is used to simulate the flow of signals in the blind spot zone. A USB cable was used to connect the Arduino Mega to the laptop that has the coding. So whenever the sensor detects any objects in its path, the buzzer starts buzzing. And it will alert the blind person to change course or stop. In this way, the person can easily find a way without getting injured. At the same time, the LED turns on where the red light indicates presence of obstacles and green light indicates where it is safe to go. The function of this LED is to alert the people surrounding the blind person. This smart stick functions similarly to the ultrasonic rangefinder. Therefore, the smart blind stick is capable to assist a blind person to move independently. Moreover, the cost needed for this smart blind stick is very cheap because we only use PVC pipe, which is needed for the main part of the body, and it will be very convenient and lightweight to move it around, and it has a good stiffness levels that does not cost much. And as of for the discussion, me and my group members have focused on the project scope because there were certain drawbacks due to the smart blind stick's system performance. So these are the several problems that we have listed down and the recommendation for each of the problems. So the first problem is, what if the disabled person is blind and deaf at the same time? So for this problem, we have come up with a recommendation by replacing ultrasonic sensor and buzzer with vibration sensor, which will solve the problem as it will vibrate the whole stick when the disabled person holding the stick. So it will eventually vibrate the disabled person's end, indicating there's an obstacle in front of them. And for the next problem is the buzzer beep is not loud enough. If the place was not constrained, the sound frequency will dissipate in a vast space and did not catch by the eardrum. So for this issue, we have created another recommendation, which is creating a funnel which will direct the sound facing towards the user. We will fix the funnel at the buzzer, and which will be facing towards the disabled person, where they can hear it much more clearly. And for the last one is, the battery will drain faster if we don't include any switches, even though the battery can easily be taken out. But for the blind, it will be difficult to remove them because they are blind. They can't see where to take out the battery. So for this problem, we have come up with a solution by replacing the battery with a rechargeable battery and fix a sonar panel on the device where it can charge the battery at the same time. And at this point, it won't be difficult for the disabled person to remove and charge the battery. It will be all done by the device itself. Thank you.
As a conclusion, this work has been done very well to design and build a smart walking cane for the blind. The objectives for the project managed to be obtained. The smart stick is a tool that can be used for both inside and outside mobility for visually impaired people in the next phase of more supportive apps. The blind walking stick has now been developed into a prototype that may be used to assist the visually impaired person. The device can detect obstacles within short distance in the user's direction. It can be gotten for a low price, safe, lightweight, low power and efficient. In addition, the system takes precautions to protect their safety. This initiative will benefit all blind individuals throughout the world by making walking simpler for them. That's all from us. Thank you.